Hello friends, good evening. Hello.
Good evening, sir.
Yeah. So we are going to discuss briefly and quickly all the points concerning measurements. Okay. Now what I am doing here is measurements pertaining to physics practicals. Okay. Yeah. And most importantly, now if you see the when you have to report the answering, you have to be very careful when you write the final answer in your examination. You have to take note of the significant numbers, significant digits, rounding off, the data that is given. There are some rules for that. So you have to follow that and you have to report the answer. So therefore, this particular section, I think I'll take about 3 or 4 classes where we'll discuss all these things in detail. Okay. Now to begin with, significant figures, right? So here you see, one thing all of you should know. I will write some number. I'll write some number, any number, say 2048 or some number, or a number obtained as a process of measurement. Understood? See, I can just give some arbitrary number like this and discuss about significant digits and vagara all about it. Or I can discuss about a number that I get out of measurement. Okay. Now the way to handle these two numbers according to the rules is very, very important. You have to give importance to that. Therefore, when you read this, significant figures in the measurement. Understand? See, if I simply write a number like this, how many significant digits are there? It is, 4, whatever it is. But from a measurement, there is slightly something more involved. I want you to focus on that. So, significant figures in a measurement are the figures or digits that are known with certainty plus one that is uncertain. Right. So, significant figures in measured value. See, again and again I am using the word measured. Measured value of the physical quantity tell the number of digits which we have confidence. Larger the number of significant figures obtained in measurements, greater is its accuracy, vice versa. Okay. Now I am sure all of you remember this when you have studied this, sometime during the theory. Now quickly let me explain this to you, just for the benefit. See, now I have a scale 0, and say this is 1, and this is 2, and so on and so forth. Say centimeters. Okay. Now I will keep an object here. Say something like a pencil. Right? Okay. Now tell me, after reading this sentence, what is the length of the pencil? The length of the pencil. Tell me. Quickly.
Greater than 1, not precise.
Okay, everybody tell now. I want everybody to answer now. Now it is high time. I want everybody to give your answer. Right or wrong? Come on. Adil gave his answer. Greater than 1. So I am asking what is the length of the pencil. He is telling greater than 1. God save you.
1.5.
1.3
centimeters and at least.
So Abhinav is telling 1. Something, your voice is gurgling. Abhinav says 1.5 centimeters. Okay. Anybody else?
Sir,
you
need to put another digit.
You need to put another digit. Why?
Sir, because 5 is 1.5, so sure this thing, so the answer will be the digit.
No man. Aditi's and others, Prabhu's and all. Prabhu, you are in college discussion again. Come on, I want you to answer today, Prabhu. Hello. Prabhu, answer mada. ರೀ ನಿಮ್ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡಬೇಡ್ರಿ. ನೋಡಿ ನೀವು ಪಟ ಪಟ ಹೇಳಬೇಕು. ಎಲ್ಲರೂ ಮೈಕ್ ಆನ್ ಇಟ್ಕೊಳ್ಳಿ. ಕಲೀರಿ, ಕಲೀಲಿಕ್ಕೆ ಬಂದಿರಿ. Come on, tell the answers. I want to teach you. I want to know where you are going wrong. Come on, help yourself by helping me. Fast. Any other student? Aruna. Hello.
Yes, sir.
What is that you have discussed about in the synopsis of unit measurements now? This is the basic question I'm asking. You must see, I think you are not alert in the college then. Okay, it's not the thing. Now see, now somebody, Mr. Adil, if you say greater than 1.5, that is not the way to answer. I have given a pencil, I have asked to answer. And I told you to read this and tell me the answer. Even after reading that, can you not tell? Significant figures in a measurement are the figures or digits that are known. What is known here? One thing is known, that this pencil is greater than 1 centimeter. That is known, 100%. With certainty, plus one that is uncertain. Now I can say the length of the pencil is 1.5. Some student will tell 1.6 centimeters. Some student will say 1.7 centimeters. So on and so on. Now, who is right? All of them are right. Clear? Okay, so what it says, you have confidence in this digit, because as you see here, it is just greater than 1. And the second one is a guess. That is an intelligent guess. Okay, so you can guess it right, and therefore this length has got 2 significant figures. Understood? One value known, other value unknown. Hello, these are all the things that you have studied, learnt in detail. Okay, did you get it?
Yes, sir.
Okay, now let me see. Now what I will do, I will between 1 and 2, I will mark the points here. Okay, so this is 1.5. Okay, this becomes 1.5. I will divide this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now tell me, what is the length of the pencil?
1.5.
1.5.
1.55.
So, good. Now everybody are answering. Now you see, in the second case, all of you know it is 1.5 are certain numbers. 1.5 is certain, but one more number you can guess. So one more number, 1.5, and one more number you can guess here. So it is, you can see the point is slightly more than that. Okay? Hello. So if you write here 1.56, 1.57, 1.54, anything, right? So all of them are correct, because these two are certain and this becomes uncertain. Correct? So now how many, see in the first case, when I had written 1, 2, the number of significant digits there were what? 1.5, the number of significant digits were 2. Okay, now how many significant digits are there? Number of significant digits are 3. Did you get it?
Yes, sir.
Please learn, yaar. These are fundas. You have answered so many examinations. Okay, done. So this is how you are going to handle. So now you see we are entering into practical physics. That means they will give you some practical situation and make you to do the measurement, like what I did here. I said, okay, I'll give you a scale, I'll give you a pencil, right? And I told you what is the length of the pencil. So you must be able to report. Clear? So now you see the measurement 1.5 and the measurement 1.55. See here the number of significant digits are both. Here the number of significant digits are less. So therefore this is more accurate than this. Okay? What do you mean by accuracy? Whatever you know, you tell.
How much the measured value is close to the true value?
Excellent. How much the measured value is close to the The closeness of the measured value to its true value. Very good. So here you see as the number of significant digits increases, okay, then the measurement is close to the true value or the real value. Correct. Well done. Well said. Okay, so that's how it is. Now you see. So I got here 1.55 centimeters. Okay. Now I will do like this. 1.550 centimeters. Any problem? Both are equal? I can write 1.55 or I can write 1.550. Any problem?
Sir, if you are writing 0, sir, you are sure that.
Pardon?
If you are writing 0, sir, you are sure that it is 0.
Why are you eating your words, man, and eating my head? Correctly, you speak loudly and clear.
Sir, if you are writing 0 after 1.55, sir, you are sure that it is 1.55 only, not more than or less than.
So if I write like this, I can write like this, provided I am very sure about these 3 digits, and I am unsure about this. So if I am very sure about these 3 digits, then I can write like this. Okay, so this becomes an uncertain number. But if I am not sure about these 2 numbers, I cannot write like this. Understood? So you cannot simply add some number there.
Sir, but will 0 not be counted as uncertain digit? Because 1.550 can also be written as 1.
Can also be written as?
In the decimal system, so will 0.
That is what you are going to learn in this chapter. See, in mathematically 1.55 is equal to 1.550. That is in mathematics. Now you are doing measurements in physics. So you cannot do this. Why? Because you see, when we write anything in physics, it has got its own significance. Okay, see, when I write the number like this, 1.5 centimeters, the length of the pencil, needless to say, what it means is, I am now using a scale which is marked like this. What is it? It is marked like this. Okay, 0, 1, 2. Okay, it is marked like this. So without saying anything, when I say the length of the pencil is 1.5 centimeters, my mind will say that, look, I am using a scale whose divisions are in centimeters. Needless to say, it is clearly understood. That is the significance of writing like this. So when I write 1.5 centimeters, so which scale did you use, sir? Did you use millimeter scale or centimeter scale? You need not have to ask me. It is very clear that you have used this scale. Supposing I write 1.55 centimeters or 1.56 centimeters, then it means I am using a millimeter scale. It is understood. And supposing I have written 1.557 or something like this, then it means I am using a scale which is, see, in between these, see, this is centimeter, this is millimeter, then millimeter is divided into again 10 divisions. Hello, got it?
Yes.
So it is understood from seeing the numbers. That is the idea of this. Okay, you see, that is what is physics all about. Physics is not, naam ke vaste write something, okay, we'll follow the convention. Everything is thoroughly discussed, okay, at the international level. And then, well, it is documented. And we just have to learn it, understand it. Okay, that is the first thing. Now let's come here. Now, learn this very carefully. Rules to find out the number of significant digits. So first rule, supposing you get a number 1984, it has got 4 significant figures. Hello, are you with me?
Yes.
Right, very clear.
Yes,
all the zeros between non-zero digits are significant. Very clear, no issues. 10806, everything. Because you are doing a measurement, obviously the zeros in between also become significant. All the zeros to the left of the non-zero digit becomes non-significant. Okay, so in this case it is 0.00108. Okay, so you can add any number of zeros behind, they all become insignificant, right? But you will see now, I'll give you some examples. You should be able to use these rules at 10. See, I am simply writing a digit. You are not told it is measurement here. If a number is less than 1, zeros to the right of the decimal point but to the left of the first one zero are all non-significant. Okay? So here you see the word used is if a number is less than this. I'll tell you why I am stressing on that word. The trailing zeros to the right of the last digit in a number with a decimal point has 4 symbols. See here 0, 1, 0, 8, 0. Only how many? This is the trailing zero to the right of the last non-zero digit in a number with a decimal point are significant. So here you see this 0 is significant, but this 0 is not significant. Clear? Hello? Yes.
In that number less than 1, sir. 0.00, sir. After the zeros, after the point, we are sure that they are 0, sir. So
you are sure they are? You are sure they are?
0.00.
Come on, continue.
0.0023, sir. We are sure that the numbers after the decimal point are 0 only. So why are they?
How are you sure?
Sir, we have written the number till 2308.
See, now try to. No, man, it's not like that. Now you imagine some measurement, where you get that value. You imagine a measurement.
Yes.
See, now listen here. Now, aram. Now think about some measurement, where you are going to end up like that. Okay. See, now if the number is less than 1, okay, number is less than 1. Okay, you have got a number there, right? So you see, you can if you add zeros to the left, it has no significance. Why do you think it is significant? What makes you to think? What makes you think it is significant? Yeah.
Suppose we have the length of it is around 0.1 meter, sir. 0.01 meter.
Okay. Now tell me a thing. The length of it is 0.01 meter. 0.01. Wait a minute. Don't rush. Now tell me, what scale are you using? Which scale are you using? Give me an example. Is it a centimeter scale, millimeters? What scale are you using? Centimeter scale. Okay. So 0, 1 centimeter, 2 centimeter. Okay. You are using a centimeter scale. Done. Now what? So now you must show me. You should tell me to draw a pencil. I'll draw a pencil here. Hello. Adil, what happened? Suddenly you go out of the air. Adil.
Hello.
What is the length of this pencil? What is the length of this pencil I have drawn here? You told centimeter scale. No, I wrote centimeter scale. I have written the pencil here. What is the length of this pencil?
0.5.
0.5. 0.5. What?
5.
You cannot write 0.55. The only certain digit is 0. This 0.5 is a guess. Over. You cannot add any more digits to that.
Yes, sir.
So 0.5 centimeters. Correct? Hello.
Yes, sir.
Now you convert it into meters. So see, now basically you have chosen a centimeter scale. Correct? That is the scale with which you are measuring. So with that scale, you have got the measurement of 0.5 centimeters. This is the certain digit and this is the uncertain digit that you can add. So the measurement is complete. Agreed?
Okay. Okay.
Now you convert this into meters. So how many significant digits are there here? How many significant digits are there in this number? Hello?
Only one.
Wrong. 2. This is certain and this is uncertain. Okay, 0 is there, but you are certain about 0, no?
Oh, okay. Yes, yes.
See, you have to apply your mind. Understand? You have to apply your mind. That's why you are learning. And only in significant digits I have spent now 20 minutes. Alright. Okay. Now in this measurement there are 2 significant digits. Okay, now convert it into meters. So what will be meters here? Hello? 0.005 meters. Clear? Right? Now how many significant digits are there?
Then here it will be one significant.
ಅದೇ ಹೇಳ್ತಾ ಇರೋದು ರಾಜ ಸಮಾಧಾನದಲ್ಲಿ ನೋಡು ಹೇಳ್ತೀನಿ ಈಗ ನೀನು ಯು ಹ್ಯಾವ್ ಡನ್ ದ ಮೆಜರ್ಮೆಂಟ್ ವಿತ್ ದ ಮೆಜರ್ಮೆಂಟ್ ಯು ಹ್ಯಾವ್ ಗಾಟ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ನೌ ವಾಟ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಇಸ್ ಯು ಆರ್ ಕನ್ವರ್ಟಿಂಗ್ ಇಟ್ ಇಂಟು ಮೀಟರ್ಸ್ ಸೊ ವೆನ್ ಯು ಕನ್ವರ್ಟ್ ಇಟ್ ಇಂಟು ಮೀಟರ್ಸ್ ದ ನಂಬರ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ಸ್ ವಿಲ್ ನಾಟ್ ಚೇಂಜ್ during the measurement with what scale you have done, that will define the significant digits. Clear? Hello? See, the measurements will define the significant digits, not the conversion. Okay? So therefore, the best way to write this is what? You should write it like this. 5.0 into 10 to the power of minus 1 centimeters. Hello, clear? Or you write here 5.0 into 10 to the power of minus 3 meters. So whether you write in centimeters or whether you write in meters, the number of significant digits is 2 only. Significant digits will imply the accuracy of measurement. Just by converting it into another unit, your accuracy will not change. Correct? That is the essence to be learned here and understood here. So this is called as writing it in scientific notation. Significant
digits will depend on which scale there is.
Significant. What did you say? Pardon me. Once again.
Number of significant figures here. That will depend upon which scale or which measurement we are using.
It will depend upon what is the measurement instrument that you are using.
Okay. Yes.
It depends on. Correct. No. See, that is why we are defining all this.
Yes, sir.
In the measurement. Supposing I give you some number and I ask you how many significant digits are there, just like this. Then you just have to follow this rule and tell so many significant digits are there. Understand? So these rules are in general. Okay? That's the whole idea behind this. Right? Okay. Thank you. Please all of you satisfy yourself. So you see here. The trailing zeros here, you see this zero becomes significant. Okay, but this 0 is insignificant. When the number is expressed in exponential form, the exponential term does not affect the significance. So you can see here, x is equal to 12.3. 12.3 you can write it as 1.23 into 10 to the power of minus 1, 0.123 into 10 to the power of 6. So here the number of significant digits will be 3. You can write it in any exponential form. Okay? Now. Let us come to this. You see here. In a number without decimal, the zeros to the right of non-zero digits are not significant. Clear? So in this 15600 has only 3 significant figures. Clear?
Yes, sir.
Now you see, but the same number recorded on the basis of actual experiment has got 5 significant figures. Because the meter can read, see the meter can read, what is the meaning of this? See, when you write 15600, when you write 15600 got from measurement, this is milliamperes, this is got from measurement, which is got from measurement means, it means these are certain and this is uncertain. And therefore, they will qualify as significant figures. Got it? But this is just a number. So the rules for just a number is different. The rules for the number obtained from measurement is slightly different. You have to understand the meaning, the reason why this significant digits are. What does it signify? So here it clearly signifies. What does it signify? That the meter that you have used to measure the current, okay, it can accurately measure up to, you say, 10th of a milliampere. Now the last digit is specifying the units in milliampere, just like this scale. This is centimeter. So so here you understood this. So here it is centimeters. How we wrote this, and if you convert, what happens? Same thing here. Clear? Understood?
Yes.
So note.
Okay.
So the previous example, if I use a meter scale and I get the measurement 0.5 meters. If I use a meter scale.
Listen, you tell me clearly what is the scale that you are using. Meter scale.
I'm using meter scale.
Okay. So meter scale means what?
Meter scale.
Hey, meter scale. 0. Then this is the first meter scale will have 1 centimeter, 2 centimeter.
Yes.
Will it have divisions in between?
It will not.
It will not have. Only this is
Not
there.
a lot.
So like that, the last digit will be 100. Correct?
Yes.
So this is what you call it as a meter scale. Okay.
Yes, sir.
Right. So the graduations are in centimeters.
Graduation science. Oh, yes. Yes, sir. Yes, sir.
In centimeters. Here.
Okay, sir. I got it, sir.
So you see, this is what I am trying to tell you. Physics is very simple, provided you follow process. What is the process in physics? It is physical, man. See, whatever thought you got, you ink it. See what I did when you asked a question, I understood where your problem is, because most of the students, they think, including me, that oh, we are very intelligent, we know. See, let me and you not show any ahankar. Simple. You have a question, you try to sketch that question. So you said meter scale. So what do you mean by meter scale? Okay, I wrote it. Then where will you keep the pencil? You said I understood the problem. So you could have yourself solved the problem. Even in examinations, you are going to get these situations. So just don't be overconfident. Okay, whatever you have thought, you ink it. Then you see, you will get the answer. Physics is the easiest subject in this universe, according to me, right? But if you follow proper process. Okay, I hope I made all these things clear to you.
Yes, sir.
So to avoid confusion regarding trailing zeros, number of decimal points, the best way for every measurement in scientific notation. See, just now you saw. Okay, so we had here, we had just now, we got this is 1.5 centimeters. Okay, so you should write it as 1.5 into 10 to the power of 0 centimeters. Got it? Hello?
Yes, sir.
So we got one more measurement. You saw with millimeter scale. You saw that? Hello? The next measurement we did that.
Yes, sir.
1.55 into 10 to the power of 0 centimeters. You saw the second measurement that we did? Just now we did no second measurement. How did you get this number? See, you remember I had first written here 0, 1, 2 like this, and I had kept the pencil.
Yes, sir.
Yes sir. Adilla, nee idraga time waste ಮಾಡ್ಕೊಳ್ಳಿಕತ್ತಿ. So first time I had kept the pencil like this, correct? Okay.
Sir, what is the question?
Question no you buy adu ತಿಳ್ಕೊಳ್ತೀನಿ. So I am writing here 1.5 centimeters. No, in scientific notation I have to write 1.5 centimeters as 1.5 into 10 to the power of 0 centimeters. That's what I have said. Now this was the first measurement. That is, I had kept a pencil like this, and it was the centimeter scale. Okay. Now the second time, what I did, I took the scale.
Divided by.
I again showed 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Areva. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? Second time, you see, I kept the same pencil. Right? And now I asked you what is the measurement. Okay? Then you said 1, 2, 3, 4, 5. Then for this you wrote 1.55 centimeters. For this you wrote 1.5 centimeters. Correct? Now in scientific notation, you have to do it like this. This one you have to report in scientific notation as a 1.5 into 10 to the power of 0 centimeters. And this one you will report as 1.55 into 10 to the power of 0 centimeters. Correct?
Yes.
So in the first case, the number of significant digits is 2. And in the second case, the number of significant is 3. Clear? Clear?
Yes.
Now, watch out. This is 1, 2, 3, 4, 5. So this, according to me, the tip is touching the 5th. Understood? 1, 2, 3, 4, 5. Then how you would have written this?
Exactly the thing, sir.
That is your perception. So if I am to see, I will write it as 1.50 centimeters. Now somebody will say, yes sir, it is 1.51 centimeters. Somebody will say it is 1.52 centimeters. Who is right? All the three are right. Correct? Now how will I report? I will report as 1.50 into 10 to the power of 0 centimeters. And second student will report it as 1.51 into 10 to the power of 0. The third student will report it as 1.52 into 10 to the power of 0 centimeters. Right? Now, how many significant digits are there in this, and in this?
All of them are 3.
Excellent. All of them are 3. So here, that's what the rules are there. Oh, sir, trailing zeros. Now be careful. When I am doing this measurement, I am writing the unit. So when I write the unit, then all these digits become significant. But if I am adding zeros here, they become insignificant. Correct? Understood?
Yes.
That is the rule. That is the rule that you have to follow. Right. So I have told you about this scientific notation. So best thing is write the scientific notation. Okay, now quickly solve this problem. Write down the number of significant figures in the following. First, yes, again, tell first. In the first case, how many significant digits? First.
3.
Okay. B, how many?
Second one,
3. Fatapat tell.
5. Third one,
Fourth.
4th one, 1.
Good. This one.
Last one, 4.
Good. So you have understood the rules. It's not just the rules. You should understand the significance of it. Okay, you should understand the significance. This is all got by measurement. I given you a very beautiful example of a pencil. Just imagine through a pencil. If you keep a pencil and try to get this measurement, okay, so you will not get. You will start with 0 and the first digit will be 2. That 0 is insignificant. Clear? Okay. Now rounding off. I think this all of you should be masters of it. There was a computation containing more than one answer. It should be rounded up to appropriate number of significant figures. So see, now there are some rules I will show you. When you multiply two numbers got from measurement, if you got two numbers got from measurement, the final answer should be what? For example, the length and breadth of this one. So this is 1.5 centimeters. This is 1.5 centimeters. What is the area? First, so you would have got 2.25 centimeters square. Correct? Hello?
Yes.
But are you going to write like this?
No.
What are you going to write?
2.2.
2.2 centimeters square. Correct? You are going to round it off to the nearest thing. So since, and you know the rules of rounding off, there is 5. And this is what? This digit is a even number. So therefore you will not add. If this was odd, you would have added to it. Correct?
Yes.
Supposing this number you would have got it as a 2.35 centimeters square. Then you would have written it as 2.4 centimeters. That's the rules. Okay? Right. Right. So if the digit is rounded off is more than 5, the preceding should be this. Okay. If the digit rounded off is less than 5, then the preceding should be unaffected. This you know. If the digit is 5, preceding user added 1 and this. Just now we did this. Done. Okay? This is irrespective of the number got from measurement or otherwise. Now, the following values can be rounded off. Come on, tell me fast. Rounded off to 4 significant digits. 4. So what will this be? Come on, write. Tell fatapat. What will this be?
36.8.
36.88. What is this going to be?
1.08.
What is this going to be? 1. Yeah. So what is this going to be? 11.12. What is this going to be? 11.13. 2 only, no?
Yes, sir. 2.
Yes, done. Okay, got it? 2 digits of now, if one digit is rounded off, then compare it with 5. If 2 digits are rounded off, compare it with 50. Okay, see that rule. 2.360. You are going to round it off to 2 digits. Okay. Right. Shall we continue? Arithmetical operations. In addition or subtraction, the number of decimal places in the result should be equal to the number of decimal places of the term in operation, which lesser number of decimal places. So here you see you are adding 2 numbers. So this has got 3 significant digits, this has got 5 significant digits. And the final answer is this. So now you must write the final answer with how many significant digits? See this is a very good example. Try to study this and understand. Now, if you by heart it simply as a rule, then you are in for trouble. I want to make it very clear to all of you. Simply don't by heart it as a rule. You understand the meaning of this? Hello? Anybody would like to comment on this? Why this is written like this? See, I am telling you students, in mains and the advanced examination, most of the students, they have got the answer right, but they have written this wrong. For example, if you have got the answer here and if you have written it as 0.87, okay, the rule says it should be what? It should be equal to the number of decimal places of the term which contain lesser number of decimal places. So here you see, here the decimal places are 3, here it is 1. So you should write it in 1. But why did they make that rule? They made that rule because, you see here, now try to understand. You see, when you...
Because
yes.
because that will be the surer digit. Sorry.
Surer means what?
Those will be the surer digit. Means we are very sure about the value.
No, you don't build the answer like that. No, wait. No, that is not the way. That's not the way to answer. Now look at this. Now, if you see this number, and if you see this number, assume they have done this measurement. They have done these two measurements. What scale would have they used here, and what scale would have they used here? Supposing both of them are in meters. Both these things are written in meters. So they must have used a scale here, which is graduated in millimeters. Correct? Hello? Hello? Sorry. If they have used, see, they have written 12.587 meters. That means this scale that they are using here is now graduated in centimeters, and this is one more digit which is what? Which is uncertain. Got it? So you are using a centimeter scale here. Hello, are you with me?
Yes, sir.
You understood what I am trying to tell you? See, you are using a scale where the least count or the least the resolution or the least count there is 1 centimeter. Got it? So therefore you have got this measurement. Did you understand?
Yes, yes.
Okay, there is this one is 1 centimeter. When they have made this measurement, 12.5 meters. Now, what is the least count here in this scale? In the scale that they have used here for this? Come on, tell if you have understood whatever I taught.
Centimeters.
In centimeters, huh?
10 centimeters. Decimeters.
Either centimeter आता है, either centimeter scale आता है, either scale है. See, now I have written in meters. So this scale is like this: 0, 1 meter, 2 meter, 3 meter. Got it? Like this. So the measurement you have done is something like this. You have got a pencil or something which is like this. And this tip here, this is, see here, this is 12 meter. So this tip is more than 12 meters. Got it now? Hello? So this tip is between the 12th meter and 13th meter. Therefore you got 12.5 meters. Got it?
Yes, yes.
But when they did this measurement, okay, so in between these two, you can see here, in between these two, they have got now, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, between this, they have divided this into 10. Got it? With that, they have done this measurement. That is why they have got this number. So when they did this, when they have done this, that is the least count of this is in millimeters, whereas here the least count is in meters. Got it? That is why they got this measurement, and when they did this measurement, they had a scale which was in millimeters. Got it?
Yes, sir.
And of course, they reported and you did the subtraction and you got this. The idea here is, see in this measurement, you can be sure about the first decimal place only, because you must now see, supposing I had used this scale and done this measurement. Supposing I had used this scale and done the measurement, then what is the measurement you would have got? You would have got a measurement, say you would have written the measurement, if you had used this scale and done this measurement, if you had used the first scale, which is the first scale here, I rubbed it up. The first scale was having only meters, 0, 1 meter, 2 meter scale. Then with this scale, when I did the measurement, I got this. Now with this scale, if I do this measurement, I would have reported the measurement as what? 12.5 or 12.6. I would have reported the measurement like this. I would not have reported the measurement like this. Okay, so therefore, the rule here, the thing here is, you must now use that scale to do both the measurements, frankly speaking. Then only you will be telling the truth. Otherwise, these two digits will be false if you have used the same scale and did the measurement. So that is why you will have to round it up to the least number of, the number of decimal places is equal to the number of decimal places of the term in operation with lesser number of decimal places. That is why this is coming. Okay, you are all keeping quiet. Okay, fine. Right. In the multiplication or division, the number of significant digits in the product or quotient is the same as the smallest number of significant digits in any factors. So here it is clear. 5.0 into 0.125 uses 0.625. The number of significant digits is 2 and here it is 3. So you should round it off to 2. First carry out the actual addition or subtraction and then round it. Okay. Now the next section is order of the magnitude of the quantity. Is the power of 10 required to represent the quantity? The power is determined after rounding off the value of the quantity properly. For rounding off, the last digit is simply ignored if it is less than 5 and increased by 1 if it is 5 or more than 5. Okay, when the number is divided by 10x, where x is the order of the number, the result should lie between 0.5 and 5. Did you understand this, or shall I explain this? You will neither say yes nor no. You are all very good students.
Understood, sir.
Tell me then. Give me an example and tell. Tell.
Sir, like they have said in multiplication or division, sir.
Pen to go, paper to go, very Okay, now you see, if I write a number 77, what is the order of magnitude of this number?
100.
Huh? So, supposing you divide it by 10, what will you get? 7.7. But the number after division, it should be between 0.5 to 5. But I am getting 7.7. So, therefore, I will divide it by 100. So, if I divide it by, so therefore, I will divide it by 100. And if I divide it by 100, what will I get here? 7.7. Okay. Still, it is not between 0.5 to 0.5. So, I will...
If you divide by 100, you get 0.77.
Thank you. 0.77. So, 0.77 is greater than 0.5, less than 5. Got it? So, what am I doing here? I am dividing 77 by 10 to the power of 2. Right? Hello. So, therefore, the order of this number is 2. X is the order of the number. Order of magnitude of 77 is 2. Did you understand? Hello?
Yes, sir. Yes, sir.
That is what you have to do. Okay? Now, 770. Okay, 770. So, you will divide it by 1000. So, you will get it as 0.77. Right? So, the order of this number will be 3. Magnitude of the order of this number will be 3. So, here is the rule. So, when the number is divided...
In rounding off, sir, rounding off, they have said that it is increased by 1 if it is 5 or more than 5, sir. That wouldn't be to an odd case, sir. Like if the number next to 5 is an even digit, then we will not increase it if the number is 5.
Wait a minute. Don't misread it. One more. The power is determined after rounding off the value of the quantity properly. For rounding off, the last digit is simply ignored if it is less than 5, right? And it is increased by 1 if it is 5 or more than 5. See, what rule you have used earlier? See here, it is increased by 1 if it is 5 or more than 5. What are the rules for rounding? See,
the increase by only if the digit is not even. If it is even, we don't increase it by 1 at all. It will stay same, even if the digit is 5. So, for example, if you consider
wait, don't go on talking. Don't go on talking. Don't go on talking like that. 1 minute. Hold on. So that are the rules for rounding off. We did. Okay. Now for rounding off, the last digit is simply ignored if it is less than 5, and it is increased to 1. It is increased to 1 if it is 5 or more than 5. So here they are not considering it as what? They are not considering it should be odd, even, and all. Correct? No?
Odd. Yes, sir.
They are not considering it. Now, what are we discussing? We are discussing the order of magnitude of the quantity. We want to find the order of magnitude of the quantity in this section. Okay. Now, supposing, see, no, wait a minute. Don't, see, now supposing you do this operation. So you end up with 0.5. Okay. Or see here, now listen here. You end up with 0.5. So here you see less than or equal to. Then the order of the number is x. But if you end up with, listen here, Aram say, here there is no greater than or equal to 5. Did you observe?
Yes, sir.
Here it is not less than or equal to 5. It is only less than 5. Hello, are you with me?
Yes, sir. Yes, sir.
So now the thing is, supposing you do a division. Say n you divide it by 10 raised to x, and you end up in 5. Supposing you say you have got a number 5000. Okay, and you divide it by 1000. What will you get? You will get 5.
Yes,
Right? So, but you are getting 5. So what is the order of this number?
It is 10,000. 10,000.
Hey, your mic is not working properly.
10,000, sir. The order of magnitude is 10,000.
ಇನ್ನೇನಾರು ಆನ್ಸರ್ ಮಾಡ್ತಾನಪ್ಪ ಈ ಹುಡುಗ ಏನು ಸರಿ ಆರಾಮ್ಸೆ ತಿಳ್ಕೊಳ್ಳು ಆರ್ಡರ್ ಆಫ್ this one is x, the value of x. So here it is 5000 divided by 10 to the power of 3. You are getting 5. Okay, you are getting 5.
No, sir, but in addition, 5%, not less than or equal to.
So therefore now you ended up with 5. But now you should not end with 5. You should end with less than 5. So therefore you will go for 5000 divided by 10 to the power of 4. Then you will end up with 0.5. Hello. So
Yes.
the order of this number,
Yes, sir.
order of
Yes, sir.
that is what you are trying to tell her. Your mic is not clear. I was not able to hear. So the order of this number is 4. The order of this number is 4, not
Yes,
3.
sir. Sir, that is to prevent a case where numbers like this will have 2 order of magnitude, sir. But that is not our concern, sir. It is like whenever there is a final digit.
Okay, fine.
Okay,
Okay, fine. So, okay. So, rounding off the digit, you use the previous rule. Never done missed out here. But anyways, now this factor is clear here. So it ends up with 5. No, it should be less than 5. Therefore, for 5,000, the order is 4. Okay? Okay. Done.
Yes, sir.
Leave it.
Yes, sir.
I'll leave it at that.
Yes, sir.
Okay, now do this sum fast. Okay, write it in scientific notation. Life will become simple. So this is 4.9 into 10 to the power of 1. This is 5.1 into 10 to the power of 1. This is 4.9 into 10 to the power of minus 2. And this is 5.0 into 10 to the power of minus 2. This is 5.1 into 10 to the power of minus 2. Write it like this first. Now you can get the order. See, now here this number is already less than 5. So the order of magnitude is 1. But here it is more than 1. So therefore the order of magnitude here, see in this case, it is 5.1. So it has to be, you have to divide it by 100. So therefore the order of magnitude of this number will be 2.
Yes, sir.
And here 4.9 into 10 to the power of minus 2. Okay. So
minus 2.
pardon?
Minus 2 is the order.
Wait here, don't keep on. Everybody are studying there. 1 minute, wait. I'm pausing to answer. You're going on screaming the same answer. Please, cool. So 4.9 into 10 to the power of minus 2. So what is the order of this number? How will you do it? I hope you understood the first 2 numbers what I did. For this, what will you do? Again you see. Abhinav, keep quiet. I want somebody else to answer. So again you see, this number is less than 5. So therefore the order is minus 2. Okay, but here it is 5. Here it is 5. Right? So what will you do with this number? What is the order of this number? Or, tell me, somebody tell.
Sir, minus.
Wait.
Sir, it is 5, sir. It should not be 5, it should be 0.
So if you divide it by 10, it will become 0.5.
Multiply by 10 to the power minus 2 is 0, 10 to the power minus.
No, no, okay, we are using that logic. I will use this logic. 5.0 into 10 to the power of minus 2. I will write it as, I will bring this one here. I can write it as 0.5 into 10 to the power of minus 1. Okay, so then the order will be 1, minus 1. Okay, correct? What I did? I pulled 10 to the power of minus 1, and this is now, because it is 0.5 to it should be greater than or equal to 0.5. Less than 5. You brought it down. Correct? Huh. So what about this? Same thing I will do for 5.1 into 10 to the power of minus 2. I will again pull it down here. I will get 0.51 into 10 to the power of minus 1. So for this also the order will be minus 1. Okay? So that is how you can handle it with this. That is why best method is write the scientific notation, then you can discourse it very easily with this. Okay, done. Come on, Baba, I have to complete this, otherwise we are very slow. The length, breadth and thickness of a sheet is so and so respectively. Give the area and volume of the sheet correct to the right. These are this. So you have to multiply length and breadth, give the area and volume of the sheet. Do it correctly now. You can use calculator and do it. Okay, in nutshell, can somebody tell me what are you going to do here?
Multiply
Which values will you multiply? So you have got here length, breadth and thickness. So what will you do?
find the value of the volume and
Step by step to tell. Step by step to tell. Length, breadth and thickness. So they have asked you two things. One is the area and other one is volume. Tell me. First you tell me the area. What length? Then no. So length into breadth plus. So this is one area. Okay. Length into thickness, one area. Plus breadth into thickness, third area. But now this into 2. Length into breadth bottom, length into breadth top. Correct now? So you will get some answer out of this. Okay. So this is as far as the area is concerned. As far as the volume is concerned, it is simple. Length into breadth into thickness. It will give you the volume. Okay? Now the question is this number that you are going to get here. That final number, how you are going to write? How many significant digits will you retain in the final answer? So your final answer, whatever you get, okay, this should be point, okay, y. It is because there are two significant digits after the least number of significant after the decimal point is this. That means whatever answer you get, you should round it off to this. Correct? That is what you have to do. That is what is the test here. It's not about multiplication and division here. As far as the volume is concerned. So, see here, as far as the volume is concerned. So, when you do for the volume, then you are going to get some number here. Assume x, point y. Now, what will be your final answer? Huh? Louder. So it should have three significant. It should have what? Yes. So this one should have three significant numbers. Okay. So in this case, what is important is the number of digits, because you are adding here. You are multiplying and adding. You should get this. So here it is only multiplication. So in the multiplication, you should reduce this to the three significant digits. And remember, this is in meter, and centimeter. Anyway, you do this problem completely and get me the final answer. And there's meters and centimeters given there. Did you understand, students? See, they can ask very nice questions in examination to bring out the truth. Doodh ka doodh, pani ka pani. Anyways, we don't have much time for you to struggle. Okay, now all of you look at these answers. You see whether you are close to these answers. So first do normal multiplication, whatever it is. Normal multiplication, whatever it is, get these numbers and so in this length and breadth, the number of length and breadth both are in meters. So you round it off to the least number of decimal digits. So it is breadth into thickness. Did you notice some important things here? Hello, see here. Hello, everybody. Give me your attention. Hello, everybody there. Hello.
Yes, sir.
Now.
Yes.
See, the most important thing is 2.01 centimeters. You are writing it like this, right? So you did this length into breadth. You got this number. Breadth into thickness. You got this number. Thickness into this. You got this number. Simple, right? Write it as it is, the number of digits. Then you rounded it off. Length and breadth. See, length and breadth. The least number of digits after the decimal point is 3. Therefore, you rounded off to 3. Got it? But here, 2.01, you convert it into meters. It becomes 0.0201. There are four digits after the decimal point. Hello? 4 digits after the decimal point. Got it? So therefore now, if you see here, this multiplication of this into this into this. So it is rounded off like this. Did you understand this? And here again, this is coming here, it is rounded off to 4. You have any confusion here? Are you sure? Why there are 4 and why there are 3 here? Why there are 4 here and why there are 3 here? Why there are 4 and why there are 3?
Sir, because the number of significant matters, right?
Abhinav, your mic is not working, man. Your mic is not working. I'm not able to hear you. It is gargling. Just a minute. I think other student was trying to answer. Please answer.
The least number of significant figures multiply by
Least number of significant figures multiply ಮಾಡಿದ್ವಿ.
multiply ಮಾಡಿದ್ಮೇಲೆ ಯಾವ ನಂಬರ್ least significant figure
ಸೊ ಇದ್ರಾಗ 4 ಅದ, ಇದ್ರಾಗೂ 4 ಅದ, ಇದ್ರಾಗ 6 ಬರ್ತದೆ. ಸೊ ಅದಕ್ಕೆ 4 ಇಟ್ಟಿ, ಹೌದಿಲ್ಲ?
ಪಾಯಿಂಟ್ ಆದ್ಮೇಲೆ 3 ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಆದ್ಮೇಲೆ 3 ಫಿಗರ್ಸ್
ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಈಗ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಏನ್ ಬರ್ತೈತಿ? ದ ಲೀಸ್ಟ್ ನಂಬರ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್. ಸೊ ಇದ್ರಾಗ 4 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ ಅದ, ಇದ್ರಾಗ 4 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ ಅದ, ಅದಕ್ಕೆ ಇಲ್ಲೇ 4 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ ಇದೆ. ಕರೆಕ್ಟಾ? ಹಾ. ಮತ್ತ ಮುಂದೆ ಯು ಹ್ಯಾವ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬ್ರೆಡ್ತ್ ಇಂಟು ಲೆಂತ್. ಇಲ್ಲಿ ಎಷ್ಟದ? ಇಲ್ಲಿ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ಸ್ ಇಲ್ಲಿ 4 ಅದ, ಇಲ್ಲಿ 3 ಅದ. ಹಾ. ಸೊ ಇಲ್ಲೇನಿನ 3 ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಡಿಜಿಟ್ ಇದೆ. ಯಾಕಂದ್ರೆ this zero that you are getting here is not considered as a significant digit. Got it?
Yes.
That is why the number of significant digits here is also 3. The number of significant digits here is 4. Got it? And again you are multiplying this with this. The number of significant digits here are again 3. Okay? So therefore you kept it like this. This is very, very important at this step. I wanted somebody to point it out. See, even though the number is written as 0.0202, 0.0801, the number of significant digits are 3. The number of significant digits 3 are 3 because you are multiplying with this number. Did you get it? Then you have added all these 3. You got this answer, multiplied it by 2. You got this. And again, when you multiply it, you have multiplied it by 2. Hello, are you with me? Hello, everybody. You are multiplying it by 2. Listen here. You are multiplying it by 2 into 4.360. Okay. How many significant digits are here? 1. How many significant digits are here? 4. So you have multiplied. So if you multiply there, you got 8.7206. So you should reduce it to how many significant digits here? So the rule here is, you see, this 2 is only a number. Got it? 2 is only a number. Therefore, this is not a quantity that is got by measurement. Got it? But this is a quantity got by measurement. So therefore, this final answer that you have got should contain what? Because you have multiplied, should contain 4 significant digits. So therefore, you are going to round it up and get it as 8.721. Understood? This is a very, very nice sum, okay, which is bringing out many aspects of this. Right. Since the area contains maximum 3 significant, rule 2, therefore rounding of the area to Now, since the area contains maximum 3 significant digits, why the area contains maximum 3 significant digits? Since the area contains maximum 3 significant figures. Rounding of area, we get 8.72. What is that? Come on, can somebody explain that? Since the area can contain maximum of 3 significant figures, you should come to this. Can anybody explain this?
So that rules minimum number of significant figures in the multiplication.
So here, okay, you can remember, if you can remember that rule. Yes, good. If you can remember that rule, fine. How I would like to do it. Now see, as I told you, I am going to use this, see here, to make this measurement I have used one scale. To do this, I have used another scale. But to do this, I have used another different scale. Got it? Hello? Understood? See, yeah, I just now explained now, man. One scale with millimeters, one scale with centimeters, one scale meters. Like that you think. Like that you think. Like that you think. And you try to get the answer. So with the scale, which has got what is like, say for example, previously I used meter scale. So with meter scale, if you try to measure centimeters, like that. Okay. So in that case, you see the least number of that is, if I use the scale used to do this measurement and do these two measurements, okay, so I would have ended up with only 3 significant digits. If I do the measurement of the length and breadth using the scale that I used to do the measurement of the thickness, I'd have ended up with 3 significant digits. Got it?
Yes, sir.
And therefore, my final answer should only contain 3 significant digits. That is how I will fit it. See, you have done your measured length with 1 foot rule, one scale, having different number of divisions. Measure the breadth with another scale, having say different number of divisions. Measure the thickness using one more scale, having different number of digits. Now, which scale is most inaccurate? The most inaccurate scale would be this. Correct? See, the scale which has got least number of significant digits. So with this, if I do these measurements, okay, then I would have got I would have got same numbers, but accuracy is different. So the final answer I will retain with the least number of significant digits in the entire operation. That is why I will have to round it up to 8.72. Likewise for volume, length into breadth into thickness, I will end up with this into this into this. So that gives me this, and therefore in this the volume contains 3 significant digits, rounding off to get it to this. Okay? Again here, we are getting this 3 significant digits, we should end up with this. And this contains 3 significant digits. It's a very nice example. I'm sure all of you would enjoy this. Now, enjoy what ನೋಡಿ ಈ ಸಮ್ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಅದ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Okay.